I think we've all had that feeling. You read the release notes for a big tech update, and
Right.
it feels like a list of purely academic incremental changes.
Right. And you're left wondering, is that really what they spent a whole year on?
Exactly. But the truth is, the most powerful changes are often hidden. They don't make headlines, but they compound over time to deliver, well, just stunning results.
And that is absolutely the core idea behind .NET 10. This isn't just another technical release. It's really a strategic investment in efficiency.
And it is a big one. This is a long-term support release, an LTS, which means it's backed for 3 full years, all the way to November 2028.
Which means a lot of organizations are going to standardize on this version.
So if you're planning that migration, you really need to know where those massive efficiency gains and the cost savings are actually buried.
Our mission today is to give you an essential guide to all of that. We're going to pull out the practical knowledge you need from the updates in .NET 10 and C# 14.
We want to show you how these new features can boost developer productivity and, this is the big one, future-proof your applications for the age of AI.
And for hyper-efficient cloud microservices.
Okay, let's unpack this. We should probably start where developers spend most of their time, right? Writing C# code. C# 14 seems laser-focused on getting rid of all that frustrating overhead, the code that isn't your actual business logic.
We can call it the Great Ceremony Reduction, and the best example of this is how they've updated property declarations.
Okay.
Historically, if you had an auto property, but you needed just one line of custom logic in the setter, say, some validation.
Ah, like checking for null or something.
Exactly. You immediately had to abandon that clean auto property syntax.
And then you were stuck manually declaring a private backing field. It was so tedious. You'd add 2 lines of code just to hold the data, all for one little piece of validation.
Precisely. You were defining structure, not behavior. C# 14 fixes this with the contextual field keyword.
So how does that work?
You can now just use the word field inside your get and set accessors, and it refers directly to the compiler-generated backend field. You never have to explicitly declare that private field again.
Oh, that's fantastic. That makes things so much cleaner, especially for simple validated objects or data structures. You can just read the intent.
You're not sifting through boilerplate, and that win is then magnified by the updates to enhanced pattern matching.
This is a feature that I think really transforms conditional logic. It moves you away from those verbose if-else blocks.
It does. It makes your code so much more declarative and readable, and safer too.
I remember reading about how this simplifies domain validation. Can you give us a concrete example? Maybe something with ranges or object states?
Certainly. Let's take range checking. Instead of messy Boolean operators, you can use relational patterns right in an if statement. Something like if score is a 90 and it equals 100.
It reads just like the business requirement.
Exactly. And even more powerful are property patterns. You can match on the properties of an object and even nest the checks.
So you could check if a person is an adult and has their contact details filled out all in one go.
All in one expression. Something like if person is name, not null, age 18, all that complexity just vanishes and the code is safer because it's null aware.
And what about data pipelines? I'm thinking about pre-processing for AI models. The list and slice patterns seem really relevant there.
Oh, they're critical. You can match against arrays or sequences structurally, so you could look for, say, a specific header sequence and then capture all the rest of the data with a slice pattern like 1, 2, dot far rest.
So let's just decompose data structures really quickly.
Invaluable for large data sets. Then there are also some nice organizational improvements with extension blocks and extension properties.
I've always found extension methods incredibly useful, but if you had 10 of them for the string class, they just felt scattered.
That grouping issue is what the new extension keyword syntax solves. It groups them all together. But the real innovation is extension properties.
So you can actually add a property to an existing type.
You can. You could add, say, a clean string computed property to the built-in string class. It just makes your utility code so much easier to organize and discover.
And there's one more thing in C# 14, a quiet performance change with compound operators. This fixes a long-standing issue, right?
It does. A subtle but important one. Before, an operator like plus had to rely on the binary plus operator.
Okay.
So if you had a custom money struct, for example, the plus operator would create a brand new money object. You'd get this temporary object that had to be allocated and copied.
Which puts pressure on the garbage collector and just slows things down for no reason.
Right. But now you can define your own compound assignment operator overloads. You can tell Plus to just update the current instance directly, no temporary objects, no extra allocations.
That's a huge deal for high-frequency systems, like in finance or data processing.
It's a very targeted optimization that gives you a measurable throughput improvement.
So C#14 makes developers happier by cutting down friction. But the runtime engine, that's where we get into the strategic advantage. This is what makes the CFO happy, because it directly impacts cloud spend.
It really is. The runtime performance gains are where those thousands of small, compounding optimizations truly shine. It's usually not one big feature.
It's the aggregate effect of making the JIT, the just-in-time compiler, smarter about every single piece of code it generates.
That's a great way to put it.
So walk me through one of those low-level improvements. What does the source material mean by improved JIT code generation for struct arguments?
So this is about something called physical promotion. Before, if you passed a struct with several members into a method, the JIT might save them to temporary memory spots and then load them into registers.
Which is just unnecessary memory traffic.
It is. The .NET 10 JIT is now much better at recognizing this. It promotes the struct members directly into shared hardware registers, which eliminates those redundant memory operations completely.
So you get a free speed boost, basically.
You do, especially if you use structs heavily, which is common in high-performance code.
We also hear about better devirtualization. In layman's terms, what abstraction overhead is the JIT able to bypass now?
Okay, so when you use a for each loop over an array, the compiler often sees it as a generic IEnumerable interface call. That call involves a runtime lookup. It's virtualized.
Right.
What .NET 10 does better is it gives the JIT an increased ability to recognize that, hey, this IEnumerable is actually just a plain old array behind the scenes.
And when it sees that?
It can devirtualize the call, it can jump directly to the code and often inline the entire operation. It erases the performance penalty of using interfaces in that context.
Okay, now let's talk about the feature that honestly feels a bit like magic: escape analysis and stack allocation. For those of us not deep in GC management, how does this work?
Escape analysis is the compiler's way of proving an object's lifetime. The JIT analyzes an object created inside a method and determines if it will ever be reachable after that method returns.
If it escapes the method.
Exactly. And if it can prove the object doesn't escape, then it doesn't need to live on the managed heap.
So it never becomes the garbage collector's problem. That sounds almost too good to be true.
Well, it's not possible if the object has to escape, like if it's returned from the method or stored in a static field. But for local, temporary objects.
Like a small array you're using for some processing.
Perfect example. If that array is proven not to escape, it gets allocated on the stack instead. And stack allocation is incredibly fast, just a simple pointer adjustment.
And when the method returns, the memory is just gone.
Instantly reclaimed. The benchmark data we reviewed was amazing. For certain temporary array uses, allocations dropped from 72 bytes down to zero allocated bytes.
That is the holy grail. Zero allocation overhead. Fewer GC collections, more consistent latency.
And this capability has been dramatically expanded in .NET 10. It now includes small arrays of reference types, not just value types, and critically, also delegates and closures.
So even Lambda functions can be stack allocated now.
If they only capture local variables, yes. The closure object the compiler creates for it can often be stack allocated, which massively slashes the memory pressure that delegates used to cause.
What does all this efficiency mean for cloud infrastructure? This is where it hits the balance sheet, right?
It is. And that brings us to data's dynamic adaptation to application sizes, which is now on by default.
Okay.
In containerized environments, your cloud cost is tied to memory usage. If your microservice allocates 2 gigs of memory but only uses 500 megs when it's idle, you're paying for wasted capacity.
You're paying for memory you're not even using.
Exactly. Data's automatically tunes the garbage collector's thresholds. When your workload is light, the GC becomes much more aggressive about releasing unused memory back to the operating system.
So it closes that gap between allocated memory and needed memory.
It does, which means you can run more containers on the same hardware or deploy smaller containers. It's a feature that directly translates into cloud cost savings.
That focus on continuous improvement and resource optimization is, well, it's really inspiring. We can achieve high performance while being smarter about the resources we use.
It really speaks to a philosophy of building platforms that enable greater efficiency and a lower environmental cost for computation, which is vital.
Speaking of smart resource management and leveraging expertise, this seems like a good moment to talk about our sponsor.
Great idea.
This deep dive is brought to you by Embersilk. If you're looking at all this technological progress, the efficiency gains, the AI readiness, and you're wondering how to apply it to your business, Embersilk can help.
Whether you're grappling with AI training, automating business processes, or just need world-class software development expertise, they can help you uncover where intelligent agents and modern frameworks could make the biggest impact.
If you're looking to leverage the speed and innovation of platforms like .NET 10, check out embersilk.com for all your AI and development needs.
So let's move into web development, minimal APIs.
Yes, they've been maturing so quickly, and ASP.NET Core 10 seems to bring them to a whole new level by adding really necessary features like validation.
Oh, absolutely. They gain critical robustness. The whole point of minimal APIs is brevity, but without validation, they just weren't quite enterprise ready.
So how does a developer turn that on, and what's the benefit over just, checking the model state manually?
It's super simple. You just add one line in your startup code, builder.services.addValidation. That's it.
And the framework handles the rest.
It intercepts the request. If validation fails, it automatically returns a 400 bad request with all the details. It just eliminates all that boilerplate you used to write in every single endpoint.
That's great.
And for real-time apps, minimal APIs now also support server-sent events, or SSE.
Why would you use SSE instead of something like WebSockets?
Well, SSE is much more lightweight. It's focused on one-way traffic, just streaming data from the server to the client over standard HTTP. It's
Right.
perfect for things like live dashboards or showing log updates without all the complexity of full duplex WebSockets.
And what about Blazor? It also got some really important resilience upgrades. I'm thinking about that frustrating moment when your network flickers and you lose everything you typed into a form.
That was a huge headache, especially for users on mobile. You'd fill out this long, complicated form, lose connection for a second.
And poof, it's all gone when it reconnects.
Yes. .NET 10 addresses this with the new reconnect modal component, which tells the user what's happening, and the really powerful persistent state attribute.
And that attribute just saves everything.
It automatically saves and restores form inputs and component data across pre-rendering, network disconnections, whatever. It guarantees the user's work persists. It's a much more professional user experience.
Okay, let's pivot to data access. Entity Framework Core 10. This is where the platform really seems to be stepping into the AI age, especially with retrieval augmented generation.
This is probably the most forward-looking feature of the whole release. EF Core 10 adds direct support for vector embeddings in SQL Server and Azure SQL.
So you can store vectors right in your database. Why is that so critical for Airgy?
Because for enterprise apps, you need tight consistency between your relational data like customer records and the vector embeddings that are derived from that data.
You want to query both at the same time.
Exactly. By supporting vectors directly, EF Core lets you perform similarity searches, the heart of R, right within your normal LI&Q queries, against your existing database. No need for a separate vector store.
That simplifies the architecture for building AI-powered apps dramatically.
It also adds full support for the new JSON data type in SQL Server 2025. You can map complex properties to JSON columns using strongly typed C# classes, which is great.
But the real key is being able to update it efficiently, right?
That's the key. You can do bulk updates, like with execute update async, directly on properties inside the JSON. You don't have to read and rewrite the entire document for a small change.
And finally, there's a hidden performance win in EF Core 10 that deals with parameterized collections. What was the vulnerability there?
It was a notorious issue. When you use a list of values in an IN clause in your query, previous versions of EF sometimes generated SQL that didn't play well with the database's query plan cache.
So the database would have to generate a new execution plan almost every time the list changed.
Right, which could cause major bottlenecks. The new default strategy in EF Core 10 is much smarter. It uses scalar parameters and padding, which drastically increases the odds of hitting a cached query plan. It just stabilizes performance.
So if we step back and look at the whole picture, .NET 10 is this LTS release that delivers efficiency on two fronts. You have developer happiness from C#14 syntax, and then these massive automatic cost savings from the runtime and GC optimizations.
It truly is a platform built for progress. All that work on devirtualization and escape analysis, it means the platform is actively shedding its old abstraction overhead.
It lets managed code compete in areas that used to be reserved for low-level languages.
Ultra-low latency microservices and cutting-edge AI pipelines.
And the simplicity C#14 brings, combined with that raw speed from the runtime, it just creates this environment that's ripe for innovation.
It is. That ability to focus our mental energy on the business problem, instead of wrestling with memory management or network failures, that's what empowers us to build smarter, more durable applications.
And that leads us to our final thought for you. The platform is now built for maximum speed and minimal complexity. So how will you leverage this new efficiency to create the next generation of solutions? Solutions that might have seemed too ambitious or too resource-intensive before? The door is wide open.
It's a truly exciting chapter for software development.
If you enjoyed this Gates Dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.